Assalamu alaikum wa rahmatullah and good afternoon to all of our beloved viewers to the Voice of the Cape's YouTube page as well as the Voice of the Cape's Facebook page. My name is Amir Adams and Alhamdulillah I have the honor and the privilege to continue this year's Matric revision session of the Voice of the Cape for the year 2024. By now all of the beloved viewers know that for this year, 2024, our main sponsor for the Voice of the Cape's Matric Revision Program is the Two Oceans Graduate Institute. If you'd like to find out more information about the Two Oceans Graduate Institute, you may contact them on the number 021 829 7015. As a reminder for those who've just joined us, this is the Voice of the Cape's online matric revision program for this year 2024, and it is proudly being sponsored by the Two Oceans Graduate Institute, which specifically is an accredited online platform where you can become a primary school or a high school teacher by studying in the privacy of your own home. If you'd like to find out more information, you may also contact them on the number as indicated earlier on, but specifically visit their website on www.togi.ac.za. Without further ado, we immediately hand over to our esteemed facilitator for today's matric revision session, who is none other than Imam Nadir Hendricks, who is the head of Supreme Scholar, and he will today be going through content for mathematics, inshallah. As a reminder to all of the matriculant students, please ensure that you like and share this link and forward this link to all other matriculant students who are preparing for the upcoming NSC examinations. And today's session will specifically be conducted pertaining to mathematics, and the content is going to be based on functions and differential calculus. So without further ado, we hand over to Imam Nadir to facilitate today's session.
Assalamu alaikum wa rahmatullahi wa barakatuh. Shukran for having me. Okay, so Alhamdulillah, we're back with another session for mathematics, and today, inshallah, we're going to be looking at functions and calculus, differential calculus. Okay, in our previous session, we looked at functions, we looked at functions and graphs, and we defined what a function is. We looked at what's the connection between functions and graphs. We looked at different types of functions and graphs that you need to know. So this is just a recap, of what we did, and we went through some exam questions. Today, inshallah, we're going to be just reminding ourselves of the weighting of the different these two sections. These are very big sections in paper one, and then we're going to be looking at another example question. We're going to specifically look at a question where a parabola and a straight line is combined. It's an exam question, and then we're going to work through that inshallah together, and then we're going to be starting the section on calculus, differential calculus. We will look at what is calculus, what is it actually. We're going to look at some derivatives by first principle examples, and we will go through some exam questions inshallah. So let's get straight into it, and let's get our hands dirty. Okay, before we do the math, let's just talk a little bit about the weightings, right? This is paper one. This is important so that you can understand, how much effort you need to put in for different sections. And at the end of the day, one of the main aims is that you get as much marks as possible in the final paper, in that 3 hours that you have allocated for completing this paper. So if you look there, you can see that the two sections that we're looking at today is quite heavy sections. If you get all of your questions right in differential calculus section, and you get all of your questions right in the functions and graph section, that is more than 40% of your paper. 35, as you can see over there, 35 marks for the functions and graph section, 35 marks for the differential calculus. Just those two sections already, just those two sections alone, are almost 40%, counts almost 40% of your paper one, right? We have mentioned in the previous section that functions actually it comes in almost all the different sections in across mathematics, in both in paper one and paper two. There's some functions and some function knowledge that you need to have in order to tackle the calculus section, which we're going to be looking at. Okay, so that's just a reminder of the different the weightings. So these two sections of paper one is very important sections that needs to be focused on. All right. So here's an exam question which we're going to be working through. I'll read the question and then we'll unpack it a little bit. So it is a question from one of the past papers, and you can go have a look there. Right? I think it's from the 2020 paper. Yeah. So the question is, they're giving you us some graphs, right? They're giving us a graph. The graph is f of x is equal to a half, open bracket, x plus 5 squared minus 8. And so that's one graph, f of x. And then they give us another, well, they give us that function, that's the function. And they give us the function for g of x, which is equal to a half x plus 9 over 2. It helps to actually know it helps a lot to know the standard forms of the function, so that you can quickly identify what kinds of functions these are, right? Which we will unpack in the as we get through this question. It is a good idea to take your time to read through the question before you even looking at the questions. Read through the contents that is given. There's a simple principle that you follow, and the principle is that we first look at what we are given and be crystal clear on what you're given. And then also you need to be crystal clear on what is being asked of you. And then you need to figure out how do you use what is given to you to get to what is being asked of you in the questions. So that's why I'm not putting the questions up yet. We first need to understand what is given. We are given a function called f of x, right? And we are given a function called g of x, and then we are given a graph. We're given some other information also. They tell us that a is a turning point of f. So there's a turning point on this graph, right? Which gives us a hint already as to what kind of graph it is. Simply by it having a turning point, we already know now that it's not a straight line, right? And you can, as you can see, if you know the shape of this f graph, right? It's a curve, and this you should be able to identify as a parabola, right? And so you should already pull some knowledge of what you know of parabolas, right? If you look at this form over here, the form of the function of f, it isn't the common form that a parabola comes in. So what form is this? So these are questions that needs to go into your mind. And then we look at g of x, and it is very clear that g of x is actually a straight line, right? And you can actually see there, if you know your standard form, m, which is the gradient, x plus c. M is a gradient, half over here. C is just some constant number, which is 9 over 2 in this case. The question is, what is this form here for f of x? So that's something. Keep it at the back of your mind. Let's continue reading. They tell us the axis of symmetry of this graph f intersects the x-axis. So this is important now to understand, right? If you look at this graph at a glimpse, you might be mistaken by thinking that this line here in the middle is actually the y-axis, but it's not. Pay careful attention. The y-axis is actually here. So this whole graph, this entire graph, is on the left side of the y-axis, which means what? It means that the x values is negative for most of this graph, because it's on the left side of the y-axis, right? So that's important to notice, right? Just to avoid making any errors. And then they tell us that point C, which is on the y-axis, is the y-intercept of f and g. Okay, so that's the information that they give us. We have some idea now of what's happening over here. I would recommend that you take a pen and paper when you come in the exam and you start writing. Just make mental notes here. I'm not doing it yet. We're going to do it soon, and then we look at the questions. Okay, so let's get into working through this section over here. Okay, so let's talk a little bit about the mental notes, right? We notice this f function over here. We notice it's in a different form, right? And we're going to unpack that. We notice that this is just a straight line, and we know that the let's just move my screen here. We know that, sorry, we know that this is in the form y is equal to mx plus c. So we can already identify the m and the c values, right? Mx plus c. Where am I writing, right? And this is in some form, right? So I want to actually unpack this a little bit because this is important. Okay, so if we look at this from this perspective over here, we have this f of x, right? I'm going to write it out But instead of putting the numbers in, I'm just going to put some letters, and then maybe you will recognize this. F of x, instead of writing a half, I'm going to put a, right? And then x, and instead of writing the plus, I'm going to put a minus, and you'll see now why I'm doing this. And I'll put, instead of writing the 5, I'll put p over here, right? Close bracket, squared minus or plus q, plus q. Okay, so there we go. So now we have this over here, and if you look at this, you might recognize this. This is the parabola in turning point format, where p and q actually represents the coordinates of the turning point. Look, we didn't even look at the questions yet. We're just unpacking what is given to us over here. So P and Q is actually the coordinates of the turning point. And this is the standard form of the equation in turning point format. Okay. So so now we have numbers. We have A being a half, we have the P being 5, and we have Q being something. There's just some technical issue here that I have. Let me just see this. Sorry about that. Okay, so we have P and we have Q. Right now, we're gonna just look quickly at the questions. Let's just see if we can get the questions in our uh, see if we can just get the questions quickly into our section over here, then we can deal with them accordingly. Um, okay, what's the first question? So the first question is, they want us to write down the coordinates of A. We'll just read it from here. Write down the coordinates of A. Okay, so we're looking at A. A is over here, right? And as the information is given over here, it says A is the turning point of F. Now, you must take notice of how they ask the question. They say, write down the coordinates. When they say, write down the coordinates, the answer is staring you in the face. And if you see this over here, A is the turning point of the F graph. And we have the turning point format. So the coordinates for A is simply going to be 4.1, right? 4.1.1. But the coordinates of a turning point, sorry, it's 4.2. Just the coordinates of A is simply going to be the turning point values, right? A is simply going to be P and Q. So we can simply just read those values from the from the equation, right? P, now here's something important. This whatever is in this bracket over here, when you take that value out, the sign of it should be negative. Now, this can be written as a half, where A is equal to a half, and then we have X minus negative 5, right? Which actually becomes positive 5 there in the original equation, squared, plus, or you can say minus 8, right? And so if we read it from here, P is actually going to be negative 5. If we take it out of there, where the positive x plus 5 is, we take it out, P is going to be equal to negative 5, and Q is going to be equal to 8. And that's the answer for question, sorry, negative 8, right? That's the answer for question 4.2.1, right? 2 marks, easy 2 marks, right? Okay. Next question is, they want us to write down the range of F. The range of F, okay. So just remind ourselves, what is range, right? Range is simply all of the possible y values on the graph. When I say y values, we're talking about the values, when we say y-axis, the y-axis goes up and down. So any possible y values on the graphs, any graphs, if you go up until the limit wherever the graph ends on top, and if you go down until the limit wherever the graph ends at the bottom, that's all the possible y values. So we take our pen and we move along the graph. And as you move along the graph on any side, it's like moving up, there's y values at every point, right? And then you see on top of here, there's an arrow. So this graph actually goes forever up, right? So there's no limit, there's no ceiling. There's no ceiling as to what the y values could be. But we know that if we go down, we will end up at a minimum y value point, and then the graph turns around and starts going back up. So that means that this graph is actually, the range of this graph at least is limited, it's got a floor, right? And so all we have to do is we have to look at the y coordinates of A, which is simply q. So, and the y values of this graph will be every single value greater than the y coordinate of A. So y, the range for this graph will be y will be greater than or equal to -8. That's it. Right? What am I saying over here? What we're simply saying over here is that the y values for this graph, it goes up forever, and it comes down to the lowest point, which is -8, and then it goes back up again. That's all we're saying for that over there. Okay. So that's another one mark, another easy one mark, if you understand what is uh, what's going on over there. Okay. Now we're looking at 4.2.3. Now they're asking us to calculate the values of m and n. Okay. I want to calculate the values of m and n. Okay. Okay. So let's just get some space here. I'll move this thing a little bit. We're going to look at the values of m and n. All right, I'll just erase this. Okay, this maybe, let's just do it here. We're looking for the values of m and n. Now, we can see over here that this point D is actually m and n, and it's on this straight line, which, remember, is not the y-axis. The straight line is simply the axis of symmetry, right? Axis of symmetry, which is the line that cuts this graph in half. Okay, so we're looking for those coordinates over there. How do we tackle this problem? How do we tackle this problem? Okay, so the first thing we need to do is we need to understand what is being asked of us. We need to understand what is being asked of us. I'm just trying to get this thing here. Okay, so we're looking for the values of m and the values of n. Well, if you understand, D is on this axis of symmetry. And for the point D, we could just change those letters very quickly. M is simply just the x value on that line. And n is simply just the y value on that line, right? So everywhere on this axis of symmetry has to be a straight line. Why? Because it's cutting the parabola directly in half. And the only way that that can be possible is if this line is a straight line. Okay, so we have that everywhere on this line there's an x value, right? If we're moving down, right? Sorry, yeah, if we're moving, if I put my finger here or anywhere on this line, the x value remains the same, which means that the x value for this point D should be exactly the same as the x value of point A, which is -5. So that means that m is simply equal to -5. And that can be read from the graph over there by understanding that that axis of symmetry is a straight line that cuts straight through it's the axis of symmetry, cuts straight through the turning point, and the point D is on that line, right? Which they actually tell us. They tell us that this point D, they say the axis of symmetry of F intersects the x-axis at E. So E is also a point, right? That's the point on the x-axis, and the line G at D, which is m and n. So D is simply a point on the x-axis, and because it's a straight line, it has the exact same x value as the axis of symmetry, which is -5, which we calculated previously. Something important to note is that when these type of questions, the way these questions are structured, oftentimes you'll find that the answers that you find in the next sections build on what you've already calculated in the previous section. So that's something just important to keep in mind, so that you understand that, sometimes you don't need to calculate. Sometimes you just look at the questions and you're like, oh my God, I need to calculate stuff, but then you've already calculated it before, right? So this is already read from question 1, right? M is equal to -5. Now it simply remains for us to find the value of n. So what is n? How are we going to find n? Well, there's a couple of ways. One of the ways is we identify that this point D is on G. And remember, G is simply just a straight line as well, right? And we've got an equation for G. So G of x is a straight line that passes through the point D, right? And G of x is equal to half x plus 9 over 2 of x plus 9 over 2. So, so what does that mean? How does that help me? Well, if you look closely, that point m and n must be on G as well. In other words, the x value of D, which is m, should be on this point, on this graph G. And whatever that x value is, the corresponding y value goes with it. So, so if we simply just take the x value, which is m, and we substitute it into the x value of G, then we will get the y value. Because remember, this is simply just going to be y is equal to a half x plus 9 over 2. Another way that we can rewrite this uh, uh, is by replacing x and y with m and n, right? Like we did over here, this is m and this is n, right? So we could say, well, n is the y value, so n is going to simply equal to a half m plus 9 over 2. That's another way that we can rewrite this equation, right? Why can I do that? Because m and n are coordinates on G. So at that point over there, where we have n must be equal to the graph of plus the x value, I mean, the function, we're substituting the m and n values into the equation. And so now it remains, well, we have a value for m. So then we simply substitute our value for m, and we get n is equal to a half. We have -5 over here, plus 9 over 2. Half times -5 plus 9 over 2. And from there, it's now just some algebra for us to we just need to do some algebra, and we will have the answer. Okay, let's get the pen here. Okay, so then a half multiplied by -5 is simply going to be -5 over 2. So it's going to be -5 over 2, -5 over 2 plus 9 over 2, right? And if you remember from your fractions, denominator is the same, so I can simply just add the numerators. I can take that negative to the top over there. You can do this in a calculator as well. You don't need to do all of these steps. Well, it's always better to do as much steps as possible because they do give you marks for the steps, right? And then if we do this calculation, which I'm not going to focus too much time on now because we are in a different section, you are expected to know this by now. Simply what you will do is you will say 9 minus 5. 9 minus 5 is 4, so it's 4 over 2, and the final answer is going to be 2. You could say 9 minus 5. Some people might be wondering, how did I say 9 minus 5? Well, you could also say -5 plus 9. I just swapped it around because it's easier to say 9 minus 5. -5 plus 9 is exactly the same as 9 minus 5, which is equal to 4. And the final answer for this question is 2. Therefore, the conclusion is that n is equal to 2. And you have your coordinates. N is equal to 2. So that's the answer to 4.2.3, right? They will give you a mark for, I didn't go through the mark allocations, but they will give you, for question 1, they will give you 2 marks. 1 mark there, 1 mark there. For question 4.2.2, you'll get 1 mark. And for this question over here, they have 3 marks. 1 mark you will get for identifying M. 1 mark you will get for the substitution, this part over here, right? And then the last mark you will get for the answer in. Okay. So that's that section over there, right? So we've done 4.2.1, 4.2.2, 4.2.3. Okay. Now there's a very interesting question that they're asking for 3 marks. They're asking that you must find the area of this shape OCDE. This is an interesting question. Find the area of the shape OCDE. Okay, so let's tackle this question. This is a combination of some analytical geometry. Yeah, let me just get my eraser and see if I can erase that. Okay, cool. So we're looking for the area of O, C, D, E. Right? We're looking for what is the area here. Okay. So there's a couple of ways to look at this. One of the first things that we would want to do that could help us is to try to identify shapes that you know, because you want to calculate area. Right? We're going to do it over here at the bottom. We want to calculate area. What do I do over here? Well, if I can identify shapes, that I know the area formula for, then that would make my life very easy. If you look closely, you will see that you can actually get two shapes from here. You can get, sorry for my skew lines, but you can get a rectangle, D, and I make that point over there, D, whatever you want to call that point, OE, that's a rectangle. And then the top over here is simply just a right angled triangle. Okay, let's call this point, uh, I don't know, what do you want to call it? L. Doesn't really matter what you call it. Then DCL will be a triangle, a right angle triangle, triangle DCL, which you know the the formula for, uh, the area of triangle DCL. It's just writing this a bit weird here. Is simply equal to half base times height, isn't it? Half base times height. That is going to be the the formula for the area of a triangle. And then we have a rectangle, and the rectangle is, so if we're looking for the area of a rectangle, and that rectangle over there is rectangle DLOE, right? The area for rectangle is simply going to be a base times height. Base times height. Okay. So now it remains for us to simply get a value for the base and a value for height. Well, we're going to make the base EO, and then we'll make the height OC, or in the case of the triangle, OL. Sorry, LC. So here by DLC or DCL, whatever you want to call it, right? We're looking for the length of the base. Well, the length of the base is simply from that point D to the, remember, this is the y-axis. So all you have to do here is you have to count how much x points do you have to move to get to D. And that is already given in the previous answer, it's -5. So I have to count 5 points from point L here that I made until D, right? Now remember, we're not interested in the negative or the positive. That negative simply tells us that we're moving to the left side of the Cartesian plane, right? We're simply interested in the distance from D to L. The distance from D to L is going to be 5. So we can say here DL is going to be equal to 5, right? It doesn't make any sense to make a distance negative. Distance is always positive, right? So we're simply just interested in the value, which is 5. And we're interested in the value of LC. How are we going to find that? Well, that's the height of this point over here. So we don't actually know what the coordinates of L. Well, we do actually. We can actually find the coordinates of Ly because it's in line with this point D over here, right? And the point D simply has a, if you're drawing a straight line, a horizontal line, then the it's the y value is constant on this. Why? Because it's cutting the y-axis, and everywhere on this y line you simply have the exact same y value. So then the point that we're looking for over here is simply what is the y value of D, which is simply just n, right? And that value of n we already calculated to be 2, right? So we have 2, and then we're looking at the point C, right? We're looking for how much points do we have to move up to get to the point C? Now that point C, if we remember earlier, that point C is simply the y-intercept. And if you remember, the y-intercept is simply just in the equation, it's simply just the C value, the constant C value in the graph g of x, right? So that C value over there is going to be 9/2, and the L value is going to be, or the y value of L is going to be, what did we say? It's going to be, did we say 2, right? So now it simply remains for us to find the difference between these two. 9/2 minus 2, right? And if you calculate 9/2 minus 2, you could do it manually, right? Then you're going to get the value of 5/2. So you could do it, take 2, take 9/2 away, and you will get 5/2, right? Yeah, so that would be the difference there. because we're looking for the height. Remember, we're looking for the height of the graph. So the height of it's actually 5/2. If we say 9/2 minus, let's say 2/1. Look, and you don't have to complicate this. You can simply just put this into a calculator, and then you can find the answer. And if you say 9/2, 9/2 is just 4.5. 9/2, 9 divided by 2 minus 2, right? It's 2.5, which is just 5/2, right? So that's equal to 5/2. So now we have our base and our height, right? And so now we can calculate the area of our triangle DCL. So this is going to be equal to a half times the base, which we said was, what did we say the base was? Base is 5 times the length from L to C, which is 5/2. And if you put that in your calculator, you will get the answer. We can work this out by hand as well. Multiplication is the easiest thing with fractions. 1 times 5 times 5 is going to be equal to 25. And 2 times 1 times 2 is going to be equal to 4. So the final answer is 25/4. Well, the final answer for the area of the triangle. And then it remains for us to calculate the area of the it remains to calculate the area of the rectangle, right? Well, the same thing applies over here. We're looking for the length for base, and the length of the base is exactly the same. It's 5. And what is the height of this um, rectangle? And as we calculated earlier, the y coordinate of L is 2. So it means from 0 to 2, that's just 2 units. So it's simply going to be, the height is simply going to be 2. And then we say that's equal to 5 times 2, which is 10. And now we have the area of our rectangle, and we have the area of our triangle. And all that remains now is that we add those two heights, or those two areas, and then we get the answer. So the final answer is going to be 25/4 plus 10. Right? If you do the calculation, you're going to get a nice value of 65/4, which is simply going to translate to 16,25. That is the area of that shape over there, which is actually just a trapezium. So there's different ways you could have actually, if you know the equation for the area of a trapezium, you could actually just calculate that as well. Okay. All right. Now let's look at the last question over here, which is for 2 marks in this section. They're asking us to determine the equation of G prime, right? Or that's G, that's the inverse of G in the form y is equal to. So what do we want to do here? They simply want us to take the equation G and find the inverse. So how do we do that? Let's remind ourselves. Our board is quite messy over here. Let's just clear up. Let's just give ourselves some space. I'll just erase over here. Okay. So we're looking at the inverse of G, which is written like this, right? And whenever we write the inverse of a function, let's just write the original function over here. The original function is g of x is equal to a half x of x plus 9/2, right? So if that's the case, then then the inverse, which is g written like that, is going to be where we swap the x and y values. Remember, this is just y values, right? So the way we can find the inverse of any graph is we swap the x and y values. You put the x on this side and put the y on that side. So the inverse is going to be x is equal to a half y plus 9/2. That's the inverse. But we can't leave it in that form because they asked us specifically in the question to write it as in the form y is equal to something. So now we need to just do some algebra, right? So if we do some algebra over here, I'll do it with you guys. We take the 9/2 over, then we have x minus 9/2, right, is equal to a half y I'm going to do this very quickly. There's a different way to do this, but we just want to get rid of this coefficient in front of y with it. So we divide by half of both sides. We divide by half here, and we divide by half here, right? And that simply means that we're going to have, if we do that, that y of that half cancels out and that half cancels out, and we have x minus 9 over 2 over half. But we obviously can't leave it like that. That's the equation, y is equal to x minus 9 over 2 over half. But we can't leave it like that, right? We have to simplify it. So we have, the way we do it is we break it up. It's x divided by a half minus 9 over 2 divided by a half. So it's a fraction on top divided by a half. And when we divide by a fraction, it's the same as multiplying by the inverse, right? Remember these small little tricks. So this is simply going to be, well, it's dividing by a half is exactly the same as saying multiplying by the inverse of a half, which is 2. So this is going to be 2x. Okay. Minus, and 9 over 2 multiplied by 2 is simply going to be 9. So then we end up with the function, or the inverse of g, which is y is equal to 2x minus 9, and you can write it that way, you can write it the other way, but that's the final answer. Y is equal to 2x minus 9. Okay, and that would be the inverse of g, and that would be with 2 marks. 2 marks. Okay, you will get a mark for doing this. You will get a mark for the for swapping, for knowing that you need to swap the x and y values. That's 1 mark, and you get a mark for the final answer, which is that over there. Okay. Okay, we are approaching the end of, closely approaching the end of our session. The next section that we're going to just look at a little bit, I actually wanted to do a little bit more, but the time is moving. So the next section that we're going to look at is what is calculus. Okay, so that's all that we're going to do for the graph section for now. But now we're going to just shift and look at what is calculus. Okay, what is calculus? Calculus is simply about looking at how things change relative to each other. As you see there on the screen, calculus at change, or rates of change, if you want to call it that. Right? That's what calculus is all about, rates of change. We are interested in how values change relative to each other. Meaning, if I hold one value constant, what happens when I change another value relative to that value? What happens? That's what calculus is interested in. Calculus is interested in rates of change. That's what they call it. Right? It allows you to find things, do calculations of things that are moving. For example, a very real life example is you want to know the change in speed of a car rolling to a red robot, for example. The car's rolling, it's moving. You want to know how is the speed changing as the car is moving to a robot. You will use, that's a typical problem. If you want to solve that problem, you will use calculus and the rules and principles of calculus to solve such a problem, right? And then we have to look at, whenever we're looking at specifically at derivatives, we have to look at what is this concept of limits. This concept of limits. Okay. So what we're going to do now is I'm going to quickly just clear this board over here, and we're going to unpack this idea of limits and this first principle equation. We're going to look at that, and then in the next session, inshallah, we will unpack some more questions on this. Okay, so what is this idea of limits? For this, I'm going to draw a Cartesian plane, a x-axis and a y-axis, right? And what we're going to do is we're going to draw a straight line. We're going to draw a straight line, and I just want to show you something very interesting with regards to calculus. So a straight line, and this is a straight line graph, right? And we're going to put some values over here. So let's say the value here is 1, and we have 2 on the y-axis, and we have 3, etc., etc. And obviously at the bottom we have -1, -2, which you should know, right? And then obviously on the x-axis the same. We will put this value 2 here. Just write this in 2s, 2 and 4. And then obviously on this side, this value over here, it's not drawn to scale, but this value over here, the x value is -2 and -4 and so on. Okay. All right. So what are we looking at? The equation of this line is y is equal to 3 over 4 x plus 1. That's the equation. For the example that I'm going to give you now and explain to you some important principles of derivatives, we're going to just look at this quickly. So that's the equation over there. Now, what are we interested in over here? We are interested in, if we look at this point over here, maybe I should just do it in a different color. I'm not sure if I can change my color over here. Yeah, I can. We're interested in this point over here, which has an x value and a y value, right? The x value corresponds to the x-axis, and the y value corresponds to the y value over here, which is going to be 4. Right? Get my thing over here. So that coordinates over there, that point over there is going to be 4 and 4. Okay. And then we have coordinates over here for this value over here, which is going to be 1 on the y-axis. And here it's going to be, well, 1 on the y-axis and 4 on the x-axis. Okay, that point over there. So we're interested in this point. We're interested in this point. We're interested in this point over here, right? Which is these coordinates over here, right? Okay, what are we doing here? If we look at the height of, or the distance from that point over there to the end over there, then that will be simply, this is 4. So we will subtract 4 on the y-axis minus 1, and that will be 3. And if we look at the distance from 1 to 4, we will have, sorry, from 0, remember, we're moving on the x-axis. This is 0 on the x-axis. From 0 to 4, the distance here will simply be 4. Right? Now, something important that we need to look at is that when we want to understand rates of change, we want to ask ourselves the question, as we move along this line, how is the y values changing as I move to the right? Or you could ask the question in the same way, how is the x values changing as I move up? And simply what's happening over here is, if I move from, call this point A to point B, right? Then as I move from point A to point B, the y value increases actually by 3 units as I move from point A to point B. And as I move from point A to point B, the x values increase by 4 units. This is what we call rate of change, right? And that's actually what's happening when we look at this over here, right? So this is another thing that you also know is this is actually gradient. Gradient is when we take 2 points, let's call it, we can say gradient m is going to simply be equal to the rate of change. They call it rate of change, or like if you take two values, y2 minus y1 over x2 minus x1. This is something that you know, right? x2 minus x1. In this case over here, y2 and y1 will be, we'll take the y value here, y2 over here, and the y value over here, y1 over there, which is going to be 4, the y value over here, 4, minus the y value over here, which is going to be, sorry, am I just trying to get this right here? So we have 2 points. We have this point A, which is, let me just get this right. Point A, the coordinates of point A, the x value of A is 0. And the y value of A is 1. And then we have this other point B, which has an x value of 4 and a y value of 4. Yeah, there we go. And so this is going to be y2, and this is going to be y1, and this is going to be x2, and this is going to be x1. And then when we subtract the two values, we have y2 minus y1, which is 4 minus 1, 4 minus 1 there. And we have x2 minus x1, which is 4 minus 0. And then we get the gradient, which is simply 3 over 4. Now, how does this relate to derivatives? Well, you could do this. You could have this very similar graph, same graph, right? Instead of having these values, we do something similar to this. What we do basically is, I'll draw another one over here. This is important to understand, right? And you will see that there will be a function that will come out of here that you actually know, that you deal with in derivatives. And then, in the next section, inshallah, we'll unpack what is happening with that function. So that is how it works with a straight line. That is how it works with a straight line. If we look at a curve, right? It's a curve over here. And we try to do something similar to this. We identify 2 points. Remember, curve is turning. It's not moving in a straight line. It's turning, right? This looks like it's turning over here, but sorry for my. Okay, we can say it's turning over here. That's fine, right? We identify 2 points. Let's call it A and B. Right? We'll call this A. Call this B. But when we don't have coordinates, we just call this graph f of x. Right? Just bear with me. You're going to see now what we're going to have over here. If we call this value over here, so we have A. A has got an x coordinate, obviously, and the x coordinate we call x. And we don't have a value for the y coordinate, but we know that this is a function. And we know that from functions, we have that y and f of x can be interchanged. So we can actually just call this y value f of x. Right? That's the coordinates of A. And then what I'm going to say here is that there's a line over here. The distance between A and B on the x-axis is going to be h. So this is going to be some point x. The distance from here to here is h. Then the coordinate here on the x-axis is simply going to be x plus h. Okay. Just tell me that makes sense. X plus h. So we took some random number h. We said, okay, for A, the coordinates is x. And if I move to B, I'm simply just adding h, which is just the length between A and B on the x-axis. Then the coordinates for B is going to be as follows. What's the coordinates going to be for B going to be? Well, the x coordinate is going to be x plus h, right? Whatever h is. The x coordinate is going to be x plus h. We're following the exact same principle. The x coordinate is going to be x plus h. And the y coordinate is going to be simply just the function f of x plus h. Simply just the function f of x plus h. This looks a bit weird, but just follow me, right? We take, when we're looking for the y value, we're simply taking the value, the x value, and we're plugging it into the function, and we get the y value. That's what we mean by f of x plus h. Now, if you look at this over here, right, you might be seeing what we're bolding over here, but if you look at this over here, and you try to write down the gradient, you apply this into the gradient formula. What's the gradient formula? Y2 minus y1 over x2 minus x1. So we say m is equal to y2 minus y1 over x2 minus x1. But instead of putting y2 and y1 and x2 and x1, we're going to put the values that we've just got there for A and B. Right? Then we're going to get something interesting. Sorry, that x looks a bit weird. We're going to get something interesting over here. x1. Okay. So now I'm saying that this over here is x. Let's say this is x1 and this is y1. And this is x2 and this is y2. Right? Then if I substitute these equations over here, I want to call it equations or expressions rather, then we're going to get m is going to equal to, well, y2 f of x plus h, f of x plus h minus y1, which is just f of x, over x2, which is x plus h, right? Put that in brackets. That's a single thing, minus x. Now you will see something building over here, right? This is actually showing us the relationship between derivatives and gradient, right? Now, this is actually, we can't call this exactly gradient because this is a curve, so we call this average gradient. Average gradient, right? Call it average gradient because it's a curve. It doesn't give us the exact gradient, but it gives us some idea or some estimation of how the slope is actually increasing as we move to the right or to the left, from whatever angle you look at it, right? So this equation over here, you might remember this equation is actually the equation of first principles. F of x plus h minus f of x over 8 over x plus h minus x. Maybe it's not that obvious yet. But if I simplify this bottom over here, x plus h minus f of x, if I say x minus x, right, can do that, then I'm left with h, and I'm left with f of x, sorry, f of x plus h minus f of x over h. And that is actually, well, you can see that it's the average gradient of a curve. It's the formula for average gradient of a curve. And at the same time, it's the formula that is used in first principles to calculate derivatives. Right? So when we're looking at derivatives, we are interested in, so just to bold the formula of the first principles derivative, gradient at a certain point, it is the limit as h tends to 0 of that function over there, as h tends to 0 of f of x plus h minus f of x over h. Minus f of x over h. Okay. And why do we say limit as h tends to 0? Well, remember we said that we're trying to calculate, when we're busy with calculus, we're trying to figure out what happens when you change one value, what happens to the other value. So we're saying, okay, we're changing this value, we're moving this value of h towards 0. In other words, we're moving this line B towards 0. And as we're moving it towards 0, the obviously the shape at the bottom, the space at the bottom of this graph is actually getting smaller and smaller and smaller and smaller. And we are interested in what happens to the y coordinate, or the f of x, as we move it towards 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 the a value, as the h tends to 0. Obviously, if it's tending to 0, it's getting smaller and smaller and smaller and smaller and smaller and smaller. We are interested in what happens to this function as we take this number, this arbitrary number h, and we shrink it until it gets to 0. This is actually the formula for derivative f prime x, and it also happens to be the formula of the gradient of a function at any point. Sorry for that weird over there, right? So I hope that this shows you the relationship between, this is also at the same time, it's the gradient at a certain point, right? It's a function of a gradient at a certain point, because we showed you there that we use gradient formula basically. So we can write here gradient at a certain point. Gradient at a point on f, right? Just do that over there. Gradient at a point on f is equal to the derivative of the function, and it's equal to this over here. The limit as h tends to 0, which is this h over here that we, of this arbitrary number that we added to h, right? And we're trying to shrink that number, change that number, make that number tend towards 0. And as it tends towards 0, we're interested in what happens to the entire function. Right? So that is, in a nutshell, how we get this formula, which we use for first principles. Limit as h tends to 0 of f of x plus h minus f of x over h. Right? In the next section, we will unpack how to use this function and a little bit more ideas of derivatives, which are important for you to understand. I hope this was a beneficial session. And with that, we will conclude. وصلى الله على سيدنا محمد سبحان الله وبحمده سبحانك اللهم وبحمدك نشهد أن لا إله إلا أنت نستغفرك ونتوب إليك. السلام عليكم.
Waalaikumsalam warahmatullahi. We say shukran jazakallah khair and by terima kasih to Imam Nadir Hendricks, the head of Supreme Scholar, who so beautifully conducted today's session pertaining to content of the mathematics paper upcoming for all of our matriculants out there. On behalf of the Voice of the Cape, we'd like to thank our esteemed facilitator, Imam Nadir Hendricks, for availing himself and for facilitating today's session. May Allah Ta'ala reward him abundantly. And I hope that this is a means of supporting all of our matriculant students who are right now out there preparing for the upcoming NSC examinations, inshallah. Of course, this is the Voice of the Cape's online matric revision program, and this year our main sponsor is the Two Oceans Graduate Institute, sponsoring these matric revision sessions. And the Two Oceans Graduate Institute is an accredited online platform where you can become a primary school or a high school teacher by studying in the privacy of your own home. If you'd like to find out more information pertaining to the Two Oceans Graduate Institute, you may contact them on their website www.togi.ac.za, or you may call them on 021 829 7015. As a reminder, as always, beloved matriculants and all those who are viewing the Voice of the Cape's Facebook page and YouTube page, please like the video and ensure that you share this video with fellow matriculants who are preparing for the upcoming examinations. And this specific session, of course, is for all of those who are doing pure maths and we need to prepare, inshallah, for the upcoming examinations. We'd like to thank our esteemed facilitator once again, and we thank you for viewing today's session. There will be many more sessions to come, inshallah, covering different subjects, inshallah, in preparation for the NSC examinations. And from our side, we'd like to say shukran to everyone. Wassalamu alaikum wa rahmatullah. Have a blessed evening further.
Alaikum salam.